guys, welcome back to my YouTube channel. I'm Dr. Sami. So on today's video, the topic we'll be treating is calculation on electrostatics and conservation law of electric charge. Please guys, after watching this video, if you know you did not understand, please drop a comment there. I did not understand. I will actually go back and treat this video because the essence of this channel is for us to learn. And if you know that, okay, you understand, drop your thoughts, share your comments. Don't be afraid. Just drop what you feel. If you enjoyed the video, drop it. Let me know. So, and also, share to your friend. If this video teach you something new, you learn something new from this video, share to your friend. Don't be stingy. Be your brother's keeper. Thank you. So, I will be diving deep into the video. So, um, let's read out the question so that we can solve. What must be the distance between point charge Q1 26 microcoulomb and point charge Q3 47 microcoulomb for the electrostatic force between them to have a magnitude of 5.70 Newton? So now the first thing in physics calculation, the first thing to do is to write out your parameters. What were you given? Now, writing out our parameters, what must be the distance between point and they are asking us distance and we are not giving the value of distance. So therefore, let's represent distance as arrow and put question mark since we don't know the value of our distance. So the next thing we are given is our first charge, which is Q1, is 26 microcoulomb. Our third charge is 47 microcoulomb. Our force is 5.70 Newton. Now, given this, please, I want you to take note of something. There is two letters that we used to use in physics calculations, more than two. So let me give you the kind of letters you might be seeing. So you should know what stands for. U is micro, and the value in physics is 10 to the power -6. N nano, and the value in physics is 10 to the power -9. You might be seeing N milli, the value is 10 to the power -3. Please take note of this value so that you know what it stands for and you can apply it in calculation. So that is our first charge is going to be 26 times 10 raised power -6 coulomb. 26 times 10 power -6 coulomb. 0.0, if you like, you might put 0.0. Let me put 0.0 so that some people should not be confused. So 26.0 times 10 raised power -6. So we have represent our U with the value, what it represents, coulomb. So the next one is -47.0 times 10 raised power -6 coulomb. So now, getting to this level, the next thing we need is to write our formulas. And I've given you the formula for Coulomb's law. It is F equals to KQ1 Q. Now in this scenario, Q3 over R square. So now our Q3 is this, we are being given Q1, we are being given R, we don't know, that's what we are looking for. Our F, we are being given. K is a constant and it has its own constant value, which is 8.988 times 10 raised power 9 Newton meter square per coulomb square. So that's the value for K. So that's the value for what? For K. So now let's apply what we are being given in this formula so that we'll get our what? Our distance, which is R. So our force is 5.70. 5.70 equals to our K is 8.988 times 10 raised power 9. We are applying this formula. Anywhere you see F, put the value for F. Equals anywhere you see K, put the value for K. Anywhere you see Q1, put the value for Q1, which is this. So Q1 is times 26.0 times 10 raised power -6. Now, anywhere you see Q3, put the value for Q3, which is 47.0 times 10 raised power -6 over r square. So now I want you to take note of something. This minus, because this minus, you don't need to use it in calculation. It is insignificant in calculation. What this negative means is that, what it's trying to tell you is that, the first q1 is positive, and the q3 is negative. What he's trying to tell you is that, unlike charge, we attract each other. That's what he's trying to tell you. So you are not to use the negative in calculation. He's just trying to pass a message to you that, unlike charge, we attract each other, and that is the force that will have this force of what? Attraction. So that's just it. So now, for further solving, we have to what? Cross multiply. So cross multiply, we have this times this, which is now 5.70 square. And we have what? 1 times everything here. What it will give us is, multiply 1 times everything here. Punch your calculator. So if you punch your calculator, you have 10.9833 as our answer. So if you multiply 1 and everything here, you have 10.9833. Okay, so after we have cross multiply, this is our value. So the next thing to do to get our r is to divide both sides by 5.70. Divide both sides by 5.70. So the reason we are dividing both sides by 5.70 is so that this can divide this, and we'll only have our arrow left, because it is arrow that we're looking for. Arrow square equals to. So now this divided by this, we point it in our calculator. So 10.9833 divided by 5.70. So we have 1.9268. Now, to get our r, it is r we are looking for, not r square. To get our distance, we need to square root both sides. So the reason we are square rooting both sides is so that square can cancel square root and we'll be left with only r. So now square root your answer. Square root answer. So our distance, value for our distance is 1.388 meter. So the unit is meter. So the distance that is between, let me illustrate what they mean for you. The illustration that the illustration diagram illustration of this question. Q1 is here. It is positively charged. Q3, and the Q3 is what? The charge is negative. So what this question is trying to tell you is that, what this question is trying to tell you is that, find the distance. So this is distance between Q1 and Q3, R, and the distance is this 1.3. So now, since this first charge is positive and the second charge is negative, what's the law of charge? Unlike charge, we do attract. So the force that will be here is force of attraction. So F, the force that will be here is force of attraction. This will attract this, and this will attract this, and this will attract this. So that's the illustration for the question. So the distance between charge 1 and charge 3 is this, and the force that will be between them, since it is unlike charge, it will be force of what? Attraction. Yeah, for the second question, the first step is to what? Write out the parameters. So what were we given? The magnitude of the electrostatic force between two identical ions that are separated by a distance. We are given distance r equals to 5.0 times 10 raised to power minus 10 meter. So, and we're given is 3.7 times 10 to the power minus 19 Newton. We're given our force, which is 3.7 times 10 raised to the power minus 9. 3.7 times 10 to the power minus 9 Newton. We are asked to look for our Q. What is charge of each ion and how many electrons? So, and our K is a constant. It is 8.988 times 10 raised to the power 9 Newton meter square per coulomb square. So our formula is still the same thing. We are still going to use Coulomb's law formula, which is F equals to KQ1 Q2 over R square. Now, if you look at this question, please let's read the question so that you take note of something. The magnitude of the electrostatic force between two identical ions. So, what did they say there? Two identical ions. So, what this means is that this formula will now be KQ square over R square. Why is it like that? The reason why we are having Q1, Q2, Q1 multiplied by Q2 in this formula is that Q1 has different value from Q2, but since it is identical, since they have um, the same value, that is, it means that Q, yes, you don't need to differentiate it by saying Q1, Q2, since they have the same value. So Q times Q is what? Is square, is Q square. So Q times Q is now Q square. So in the formula, since it is identical, and it will now be KQ square over R square. So that's what we are going to use. So our formula that we are using is F equals to KQ square over R square. So now let's put these parameters and solve so we can get our Q. So therefore, solving, our F is what? 3.7 times 10 raised power minus 19 equals to. Sorry, it's not minus 9. It's not minus 19, it's minus 9. So, and our K is what? 8.988 times 10 raised power 9. So, times Q square. Our arrow, yes, we're given arrow. It is 5.0 times 10 raised power minus 10 square. So now, 10 square. Now let's use our calculator. This will be over 1 raised power minus 9. So now what are we going to do here? Cross multiply. So you are going to multiply this to this and this to this. So let's do that by punching our calculator. Fine, sir. Yes, sir. Thank you, sir. Minus. Okay. So the value is 9.25 times 10 raised power minus 28. So multiplying this together, you have this. Punch it in your calculator. Multiply this together, you have something like 1 times this times this. So it is something like 8.988 times 10 raised power 9 Q square. So now, what are we looking for is our cube abi. So we have to divide both sides by what is beside Q. So what's the value beside Q? It is 8.988 times 10 raised power 9. So divide both sides by it. Times 10 raised power 9 times 10 raised power 9. So doing this can cancel this, abi. So therefore, we'll be left with our Q square here now. Q square. So for Q square. So divide these two so that we'll have the value for this place. So this has cancelled this out. Left with Q square. So 9.25 times 10 raised power minus 28 divided by 8.988 times 10 raised power 9. So our answer is now 1.029 times 10 raised power minus 19. So we are looking for Q, so not Q square. So square root both sides. So our answer is now 3.2 times 10 raised power minus 10 coulomb. So this is our value for Q. So this is the value for Q. So moving on to the next question. So this is question A that we have solved here. So moving on to the next question. Let me quickly rub off this place. So we have to calculate how many electron for the B. How many electron is missing from each ion? So electron from each ion, it is very simple. So now to get the electron from each ion, so you just have to divide this by the value of one single charge ion. So divide this by value of one electron. So let us say, so the next charge is what? 3.2 times 10 raised power minus 10. So we are looking for how many uh, how many electron is in this charge. So it is very simple. One electron is 1.6 times 10 raised power minus 19. So we just have to divide this by this. So you know how many this you can find in this. So that's just it. So the electron is 2 times 10 raised power minus. So this is minus 10 now. So 10, 9. So this is the electron. Thank you.